Have you ever considered the large part of your life that is affected by circular motion? No? Let me give you some hints. How about this picture? Picture of a wheel, or its more current counterpart, tires that go on things like, now you're getting the idea. Yeah, every vehicle that you drive in has these revolving things that we call tires. But think about it and you know that there are a whole lot of revolving things. If you look at your dashboard instrumentation, depending on whether or not yours are digital, many cars still have needles that swing across for different gauges, your speedometer, your tachometer. Maybe you have a clock in your dash that has revolving hands. All of those have more behind them than just what you see. If you lift the hood of your vehicle, one of the things you'll see is a bunch of pulleys that with your engine running are rotating at fairly considerable speed. So understand that your life is affected by circular motion every day. Even our playtime is often affected by circular motion in the things that we enjoy. Even our pets at times are affected by circular motion. Even our daily lives sometimes feel like, well, you get the picture. So, what does circular motion have to do with trigonometry or mathematics at all? Well, that's a good question, but what you're going to see is that much of trigonometry is very important in analyzing circular motion. One of the things that all circular motion tends to have in common is how rapidly is something rotating. For instance, the pulleys in your vehicle. How rapidly are they spinning? We have that one piece of information that we usually associate with things that are revolving in terms of how rapidly. These letters seem familiar? RPM. Strange looking P there, I know. Here, I'll fix it. Sometimes my pen has a mind of its own. But let's go back and consider some other options for analyzing rotational motion as well. Let's think about the motion of a wheel. And I like this spoked one for a couple of reasons. But think about the fact that, let's say, this particular wheel is rotating in this direction. And as it's rotating in that direction, this point, say, right here, is going to rotate all the way around until it comes back to being on the ground again, which we would call one revolution. And in terms of revolutions, that's okay because that's one of our typical spinning type calibrations, but because every point on that circle is going to touch the ground by the time this one gets back to the ground for its second time, what else are we going to be able to measure there? Is there a particular formula that jumps into your mind, like circumference equals pi d or 2 pi r? Now that's a linear motion, which means those RPMs are also generating linear motion, such as along the road or along your driveway or wherever you happen to be using something that has this particular wheel. So we're going to get a linear speed, so to speak, based on how many revolutions per unit of time would give us that many circumferences per unit of time. So we get a linear velocity which is kind of a fancied up word for speed, but velocity is used where direction is involved. So the difference between speed and velocity is that part of the definition. Velocity is speed in a particular direction. Okay, but suppose we want to look at, say, this spoke right here as being a side of an angle, and these other spokes being particular other sides of that angle. So maybe we could look at it as snapshots from a unit of time to the next unit of time that shows the rotation of this one side of the angle around the circle. And notice that when we start talking about that, since we're letting this side rotate as rapidly as the wheel is rotating, then we're generating angles that, if it only goes one rotation, one revolution, would be 360 degrees or 2 pi radians. But most spinning things that we're talking about just keep spinning. And I notice that I have arrows going in opposite directions here, and that's okay because we're not really concerned so much about direction as the fact that these things are spinning, such as the pulleys on your vehicles. If you look at them, nowadays you have a one belt fits all of the rotating things, and some of those rotating things are spinning clockwise while others are spinning counterclockwise. But again, how do we measure angles? We measure them in radians or degrees, or as we saw before, grads, but we're mostly interested in rotation in degrees or radians. When we're interested then in the rate at which an angle is rotating, we're interested in what we call angular velocity. There you go. Now, again, most textbooks and many instructors will go right to some formulas. But before we look at formulas, let's just be logical about it. Now, let me clean this picture off a little bit and before we talk some more. Okay, that's much better. Now let's talk about, first of all, the RPM. And I better switch to something that writes. Okay, so 1 RPM meaning, and the M here would be our units of time, so revolutions per minute. It's not always minutes, it could be seconds, it could be hours, whatever, but RPMs is good enough. And what 1 RPM is saying, it's making 1 revolution or rotation per minute. if it makes 1 revolution in a minute, then it makes 1 complete angular circle per minute. That would mean 1 complete 2 pi radians, or 360 degrees per minute. So these two combine to give us the information as to how just the spinning number relates to angular velocity. What about linear? Well, linear things are measured in inches, feet, yards, and as we mentioned before, if you're looking at a wheel, for instance, as it rotates 1 complete circle, every point on that wheel, on that tire, touches the ground. So 1 revolution would be the same as 1 circumference. Per minute. Now, let me add 1 more to that. Since we know the circumference is 2 pi r, then it's 2 pi r inches, feet, yards per minute. So here's the relationship for linear. So notice that angular and linear velocity are both related to the rate at which something is spinning. Notice that with a pulley, all of these still apply. The pulley's not actually moving anywhere, it's just actually spinning there on the front of your car, but there are belts involved, and one of those things that happens with the belt is that every point on the edge of that pulley touches the belt. So we can relate the spinning pulley to a linear motion, perhaps, for that belt. So even though it's not moving, there is still we can talk about a linear component, or we could talk about an angular component.